Hey, AoC 2023, day 10 in Rust. Got about 2 minutes and 45 seconds to set up my day 10. So let's set things up. Okay, there's a day 10 there. Let's make a day 10 test. Day 10. Tests day 10 and a main day 10. 2 minutes to go. Hey there, Code Monk. Just in time for today. Yes, good luck to you. I'm sure you'll be doing this as well. Just getting all set for day 10. Save, and we're good, I think. So, cargo, next test. Okay, and close all the things. Day 10 tests, run. Hey, look, passing. Must be 0, right? Okay. All right, so with a minute to go, quick recap of what Advent Code is. It is an advent calendar of small programming puzzles. So people use them for various things or just to have fun. But anywhere from prepping for interviews, practicing problems, speed contests, challenging each other. You don't need to have a comp sci background to participate, just need a little bit of programming knowledge to be able to solve problems with computer. So it's a pair of puzzles each day from December 1st through 25th. I'm solving them in Rust. People solve them in a variety of programming languages, including some that they made on their own. And there's a leaderboard, but I have no hope to get onto it. So I'm just going to have fun with it. And it unlocks at midnight Eastern Time, which is in about 8 seconds from now. So we're all going to read the problem together. They're Christmas themed. There's 2 of them, a part 1 and part 2. So here goes part 1, day 10. Pipe maze. Use the hang glider to ride the hot air balloon from Desert Island all the way up to the floating metal island. This island is surprisingly cold, and there definitely aren't any thermals to glide on, so you leave your hang glider behind. You wander around for a while, but you don't find any people or animals. However, you do occasionally find signposts labeled hot springs, pointing in a seemingly consistent direction. Maybe you can find someone at the hot springs and ask them where the desert machine parts are made. The landscape here is alien. Even the flowers and trees are made of metal. As you stop to admire some metal grass, you notice that something metallic scurry away in your peripheral vision and jump into a big pipe. It didn't look like any animal you've ever seen. If you want a better look, you need to get ahead of it. Scanning the area, you discover that the entire field you're standing on is densely packed with pipes. It was hard to tell at first because they're the same metallic silver as the ground. You make a quick sketch of all of the surface pipes you can see, your puzzle input. The pipes are arranged in a 2-dimensional grid of tiles. So there's vertical pipes, horizontal pipes, 90-degree bends. There's a ground with no pipe, and S is the starting position of the animal. There's a pipe on this tile, but your sketch doesn't show what the shape the pipe has. Based on the acoustics of the animal scurrying, you're confident the pipe that contains the animal is one large continuous loop. For example, here's a square loop of one pipe. So it's L, J, 7, and F. Okay, if the animal had entered the root loop at the northwest corner, sketch would instead look like this. Unfortunately, there are also many pipes that aren't connected to the loop. This sketch shows the same loop as above. Right, but there's no connections. They have to be connected in both directions. In the above diagram, you can still figure out which pipes form the main loop. They're the ones connected to S. Pipes those pipes connect to, pipes those pipes connect to, and so on. Every pipe in the main loop connects to its neighbors, including the S, which will have exactly 2 pipes connected to it. which is assumed to connect back to those two pipes. Here is a sketch that contains a slightly more complex main loop. So here, like, well, it's got to be these two, right? It's the same sketch with the extra non-main loop pipe tiles also shown. Right. Interesting. If you want to get out ahead of the animal, you should find the tile in the loop that is farthest from the starting position. Because the animal is in that pipe, it doesn't make sense to measure this by direct distance. Instead, you need to find the tile that would take the longest number of steps along the loop to reach from the starting point, regardless of which way around the loop the animal went. The following example, the square loop, it would be that J, right? So we're just going to do a flood fill, I think, until we get the highest number. Right. Find the single giant loop starting at S. How many steps along the loop does it take to get... Okay, so I think we're just going to take this one, right? The more complex one. Or should I just take both of them? Including the extra stuff that doesn't matter? Let's do that one. As like a second input. Let's have the simple one be the first example. Here's the second one, first one. So this one was 4, right? For input 1. And for the longer one, it was 8. So like 1, 2, 3, 4, 5, 6, 7, 8. There. 1, 2, 2, 3, 4, 5, 6, 7, 8. I guess 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay. So I think we're just going to parse this into a simple grid of enums. The slightly complex part. Oh, I didn't mean to run that. So the complex part is where the S is. We don't actually know the pipes around which directions to go. But I guess we can just scan up, down, left, right, and look for ones that are compatible. Yeah. All right. So let grid equal grid new input unwrap. Okay, make a struct grid and pull grid. And I'm guessing that width and height, yeah, it's arbitrary. Wow, that's crazy. Okay, so we can't just assume any particular width and height. Function new. Copy this. I'm not going to care about that. Okay, so this is an option self. Okay, so let's assume we have a grid. What are we going to do with it? I think what we're going to do is we're going to use like a flood fill algorithm, I think. And we need to know the starting point. And we're just going to continue flooding until the until we hit the last spot, and then we just take its number. So Actually, you know what we can do is while parsing this, we every position that is not an S would get like a 0, and S would get a 1, and then yeah, and then the flood would just look for um, all the ones and like spread it out, or anything that's not a 0 and spread it out to any zeros. And remember, I guess we'd remember the last. We just need, all we need to do is count the number of times, right? So we would say while grid let mute. What's the answer again? Steps. So while um, grid dot flood steps plus equal 1, right? And then it's just going to be steps. So we need to have a flood, which takes a mutable self. It's got to return a indication of whether or not it actually flooded, right? Make this mutable. Okay. So a couple things, right? It'd be convenient to know the the width and height, right? And I'm also thinking, just to make it easy on myself, let's put a dot, like a non-pipe boundary around the whole puzzle. So width, height, and then I guess grid, vector, a vector of I don't know, positions. And then let's have it remember the positions that were most recently flooded. So that was like flood. Well, flooding. Let's make that a hash set of I need coordinates. Well, I guess it's just u size, u size. Okay. So struct position. What are we going to put in the position? Type, I guess. And then whether or not it's been flooded. I can't call it type. How about pos type? Enum pos type. We got ground. We got um, northwest, northeast. Actually, how about I, just for my own sanity, make it like say which directions. So like east, west, yeah, north, south, east, west. And then we got northeast, northwest, southeast, southwest, southeast. And then how about a special one for start? And it'll just have different rules on how it connects. Okay, hash set import. Okay, so let's fill in that grid first. So indeed. So lines input. um, let's make these the rows, because we'll form the grid by adding an extra row at the first and last, and then we're gonna end up pushing an extra column at the beginning and end of each row. So lines, map. So each line is going to be line chars map uh, position new. Yep. Okay, and then we'll also need to remember what we're flooding. Mute flooding hash set new. Okay, and then I am going to enumerate so that I can get the Y positions along with the line. And the character, same thing. I'm going to enumerate that. So I can't just call new. I'm going to have to say X and C. And it's going to be position new X, Y, C. And I'm having a hard time seeing the different colors here, but this one right here, we're going to collect. And we're also going to collect out here. Okay, so position needs to have a new. Okay, so here it's X is a U size, Y is a U size, and C is a char. Self. Okay, I want a little bit more here. This is the position, and we are going to return it. But before we do so, I want to say if position dot position type equals position type start. Then we're going to go flooding insert XY. All right. Wait, what? Oh. That's two to do on this one. Yeah, we're going to have to derive. Let's just derive all the things. So clone, copy, debug, equal, and partial equal. Don't think it order doesn't matter though. Okay. Yeah, it doesn't know what I'm collecting into. I'm surprised that here, we'll just fill it now. Yeah, it doesn't know what type of putting in there because what I want to do is say let the grid equal. Well, first let the width or height equal the grid rows length plus 2. And then let the width equal grid rows 0. Actually, because we're going to enumerate again, I do need to say that this is a vector. This one's length plus 2. Okay, so the grid is going to be standard iter once, standard iter repeat, and then I need to put just a ground not flooded there. So I'm gonna want to derive a clone, copy. Actually, why don't I just take all of this and just like paste it there? There we go. So repeat a position type ground. Flooded false. Okay, and then chain to that. Oh, repeat takes I need to do a repeat and then a take, don't I? So I don't actually want to once. Actually, no. Inside the once, I'm going to do a collect. So it's going to be an iter repeat take with collect. And then to that chain, we're going to take the grid rows into iter and map grid row. And then another one of these, one more extra rows down here. And then collect all of that. Okay, so for each row, I need to take one of these and then chain it with the grid row into iter, and then add another one at the end. I don't see the... Oh. There we go. Okay, so didn't like this collect though. Type annotations needed. Oh yeah, it doesn't really know the... What if I say Beck here? Then it should know, right? Yeah. Alright, same thing here. Well, if I say grid down here, and then it'll know. Actually, it should be able to infer the width and height too. Oh, do I have to do chain once? Chain, iter once, repeat. Wait, what's the problem here? Value type chain once position cannot be built from iterate over positions. Position. Oh. If I just do that, it's a once. Okay, so chain with that. Let's see if I just do that, is it okay? No. It already has a problem with that. Do I need to like say it's a vector? I guess I do. Oh, I never collected inside here. That's why. Static? don't see why that needs to be static. What's wrong with this one? So this is called enter in function argument accepting into iterator. Is grid row an iterator? No, it's a vector. I'm just gonna keep it. Okay, so this ugly monstrosity ends up putting ground around the whole thing just to make it easier. But I have to remember to add 1 to here. And what was I going to use the X and the Y for? I don't actually think I need that. I don't think I need that. I'm going to remove that. We just need to enumerate to get the X and the Y so that we know the initial flooding for the start, right? Yeah. Yeah. Okay, so we do that, and then what flood's going to do is it's going to take all the flooding positions and then find where it can flood it to, based off of the type. So for what's it's a XY in self dot flooding. Can I just take all of them? I guess I can move it out, right? I know. Let new flooding, well, flooding equal hash set new, and then we're going to swap. So flooding, it's like standard swap, standard mem swap. Self flooding with flooding. So we get a new hash set into the self, and then flooding is what we're now going to consume here. Okay, so I guess let position equals self. We're gonna mutably borrow self. Actually, I can't mutably borrow more than once, right? So then we're just going to do a match on borrow self grid y x. Why did it not let me do that? Why is it not letting me do this? That's a vector positions. Can I not match on a position? Oh, I can't. Position dot position type. So dot position type. Now I can fill my charms. Okay, so we shouldn't be flooding the ground. So that's unreachable, right? So these are clear. I think, yeah, I think what we want from this is each pipe is only got 2 ends, right? So it only goes in one more direction. So that means we're going to get a new XY out. X, X2, Y2. Right? Start's going to be the hard one because we have to scan around to see which pipe we can flood to. Actually, the very first one, it can actually flood to 2 positions. So maybe I should make that a special one. If self grid Y. I guess we can copy that, right? So let pos type if pos type equals start, this is pos type again. I don't know why it's telling me that. Oh, because we don't have anything here. Right, so north, south. Oh shoot, we still have to like look and see. Uh, so I guess it doesn't really make it. I don't. Hmm. I think we actually want 0, 1, or 2. So there's some number of potential positions we might flood to, right? So then let's make it do this. So put it back to this. Get rid of this. Instead of let that, this will be let um, next positions. So for north south we have to go yeah, it's gonna be gosh, how do I say this? I guess we'll do it with a with a vector because I want the same type return for all of these, right? So okay, I think I know what I want to do. Um, Instead of actually returning something, these are going to call back into self. So this will say self try flood x y minus 1 and plus 1. So we need to have like a try flood. Let's remember to put a to do there. Okay, and then why is this a problem? Probably because this is not mutable. Okay, so then these will all have something similar except for start, which is going to look a little bit different. So east west is going to be minus 1 plus 1 for x, not y. North and east, so north, that's north, and east is that. North and west, west would be minus 1. South and west is plus 1 and then minus 1. And southeast is going to be, that's south and east is plus 1. So in the way start is going to look, it's going to look at all 4 directions around the start. And depending on what type they are. So how do I say that? I guess match. Well, let's make it a subfunction. Try flood start. So all four directions. But I have to say which one it came from. So like, I guess let's have another enum. So direction. If this is going north, let's say south. South. So if it leads away south, it gets flooded. So that's north. I should just put this in my clipboard. Whoa. The blue what's that blue thing there for? East. So just go with it? Go with that blue thing? Who knows what it means? I don't know. Okay, I need an enum for direction. North, south, west, uh, west, east. All right. Oh, I never did do a the parsing for new. This is just a match, right? Match C. So we'll do a self. Actually, it's just a match C. And the types will be dot is self. Position type is ground. Flooded is false. 1, 2, 3, 4, 5. So we have the special starting position, which is flooded. Oh, I need two more. So we have the vertical pipe. We have minus, and we have LJ. Seven and F. So this is north south. This is west east. Or did I do east west? It did east west. L is north east, right? North and east. J is north and west. 7 is south and west. And F is south and east. And then underscore is unreachable. All right, so all of these, I have an error here. These all have to be equal. There we go. Okay, so there's the parsing for each cell in the grid. What's this error down here? Try flood start. What's the problem? No method called try flood start. Let's add it. Try flood start has the same X and Y, and it also has a direction. Okay, so really it's flooded depending on it matters if it's a match self, not oh, I have it on a grid. Yeah, grid Y X position type, right? So ground, we do nothing. North, south. So we're going to make this whole thing an if. So if it's true, then we're going to actually flood it. So there are two things we need to do there, right? Actually, and flood, I think we need to know. No, I don't need to. I don't need to know the number actually, do I? So this is just flooded equals true. and self.flooding insert xy into it. All right, so then yeah, this is false. We never flood into the ground. So if it's north and south, then north and south, north or south is true. West, and then everything else is false. Matches? Oh, okay. So can I just try it? Matches north south. Oh, that's nice. Also, I'm gonna end up doing this for all of these, aren't I? This one is unreachable. So east and west, north and east, north and west, south and west, south and east. Cool. So try flood is different, right? It's just if it's flooded or not. So if self grid y, how come I can't type right now? Flooded. If it's not flooded, right? Then it gets flooded. And that implies doing this. Okay. Do I have any other to-dos? I have one at the end here. So oh, this tells me if we're actually flooding anymore, right? So then flood. This just returns grid flooding, or it's self, I guess. Self flooding is not empty, right? Okay, do I have any other to-dos? I don't think so. So I can try this, right? Run it. This should have been a 2. Failed. Unreachable code. We hit ground. We told it to flood the ground at some point. Okay. How did that happen? Let's just have it print out the position then. So, I got a bug. Let's see what the bug is. Uh, X1, Y2. X1. So it starts at 1, 1 at the corner, right? So right here. Somehow we flooded that from the start, maybe? So flood is called from flooding. So let's do a VBG here. See it. So 2, 4. Wait. 2, 4, 4, 2. Wait, what? One, two, three, four. How did it get to there? Oh, you know what? Yeah. Let's not debug that. It's hard to see that. Instead, I think what I'll do is I will do a DBG flooding here. Actually, then can't I just do this? DBG there. That'd be the easiest way to see this. So we're starting on the easier one, right? 2 2 goes to 3 2 2 3 4 2 2 4 4 3 3 4 4 4 and we're done, right? So then this is the second, the harder one. 1 3 is where we start. Which one did I grab? The one that has a 7 in the top. This one. We got 1 3. We start there. Then 1 4 2 3. 1 4 2. So there and there. And then 1 5 2 2. And then 2 1 2 5 and 3 2. How did that happen? 1 5 and 2 2, right? 1 5 and 2 1 5 and 2 2 is that position and that position. That makes sense. 2 1 2 5. No, we shouldn't have gotten there. How did we get there? No, that's wrong. From 2 2 we should have gone to 3 2. How do we get to, and then 2 5 is probably correct. Yes, but how did we get to 2 1? How did we get there? Must have gone north when we should have gone east. Actually, it. Okay, I think I might know where to look for the bug. The south and east, right? And southeast should be what an F is. Okay, well, let me make sure these are all correct. That's north, south, that's east, west. That's north and east. That's north and west. That's south and west, and that's south and east, right? Okay, so when we go north, south, east, west, northeast, northwest, south and west, south and east, okay. North and south, east and west. That's north and that's east. Oh, that's not south. That's the bug right there. Okay, I fixed the bug now. Is it gonna work? Yes. Okay. Cool. Let's remove our DBGs. Oh, man. I think I need a cough drop. Excuse me. Time to run day 10, part 1. 6,714. Yay! On to part 2. You quickly reach the furthest point of the loop, but the animal never emerges. Maybe its nest is within the area enclosed by the loop. To determine whether it's even worth taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. For example, that one. The above loop encloses merely 4 tiles. the two pairs, these two, are not in the loop. There's the same loop again with those regions marked. Outside, inside. Wait, why? How come this isn't marked? In fact, that doesn't even need to be a full tile path to the outside for tiles to count as outside loop. Squeezing between pipes is also allowed. Here, I is still within the loop, and O is still outside the loop. Wait, what? Okay. Both examples, 4 tiles are enclosed by the loop. Here is a larger example. The sketch above has many random bits of ground, some which are in the loop and some which are outside of it. Okay. This larger example, 8 tiles are enclosed by the loop. Any tile that isn't part of the main loop can count as being enclosed by the loop. Here's another example of many bits of junk pipe lying around that aren't connected to the main loop at all. Here are just the tiles that are enclosed by the loop marked with I. Okay. Figure out whether you have time to search for the next by calculating the area within the loop. How many tiles are enclosed by the loop? Hold on, I need to get a cough drop. I'll be right back. All right. I was looking at this, thinking that we would just, when we flood the loop, we're discovering which tiles are in the loop, right? And then we could just clear out all the ones we never hit. It doesn't matter if there's a pipe there or not, right? So the problem is though that these ones here, like I was thinking, like once we clear out all the ones we didn't hit, and then we're just determining which of those are inside and outside. I was thinking we could just flood from anywhere on the border, right? But how do we do the squeezing through like there like that? You know what we could do is we could actually create space by extending the loop or extending every spot, right? Yeah. We could, instead of making it a 1 by 1, we can make it a 3 by 3. And then yeah. Then there would be a slot through which you could so what we would do is then we if every 1 by 1 here returns into a 3 by 3, and then we flood again the from the periphery, and then it should flow between these two here and flood this and it'll be all flooded, and then we just count the places we never hit, and we only count the middle position. Yeah, because we'll hit the middle. Well, actually, we won't hit either one of these, so they won't count anyway. So we'll know that there are 4 here. Yeah. Why don't I just do that? And then what we can do with S is we can treat it as it blocks all 9 things in a 3 by 3. Because why not, right? Or do I need to replace it? I think I might have to. I think we actually want, when we figure out which directions the start one is, we got to replace it with the pipe shape that it really has, because then when we expand the map to flood and find all the interior positions, we want to have the correct shape. Okay, go away. All right. So they gave us this larger example, right? But do I want to start with the easier example? I think I do. Let's take this example here. Call that, let's just paste it there. We'll call this input 3. And all these O's are just going to replace with ground, and all the I's are going to replace with ground. Right? So this one is going to be this is input 3. If input 3, so part 2 should tell me 4 for this one. There we go. Okay. So, yeah, a little bit of adjustment here. I think when we do this one, I'm gonna want to try flood to tell me whether or not it flooded it. Actually, I guess we can tell that. Eh, let's have it return a Boolean. Let flood equal if flood flood. Okay. So why don't I just do something like match and just turn all these into commas. And then fill the match arms. So the ones that are reachable are where there are 2 places we flooded, right? So there should only be 2 trues. False, true, false, true, false, false. Okay, all the other ones are unreachable. Okay, so and we're gonna assign this back into the position type. So this one, so it's this one's north south. Okay, sorry about my coughs. South east. Southwest. Northeast. Northwest. And this is east-west. There we go. So that should not have changed our part 1 answer. So that just fixes the starting pipe. Cool. Now that we fixed the starting pipe, what we can do is we're going to flood just like in part 1, but we won't really care about the steps, right? To-dos. I don't care about the steps. So once we're done flooding, Then we want to construct a new grid where every pipe is expanded to a certain shape. Every every flooded pipe shape is expanded. Every non-flooded position is just replaced with ground. And yeah. So if it's flooded, we replace it with its pipe shape. If it's not flooded, we make it clear. So let's make the yeah, we can use the same pipe symbols too, right? Except for I guess for ground, what we do is we flood all directions. Yeah. No, we'd only flood directions that lead to another ground. Right. Okay, so we're gonna have rules in there where if a ground is flooded, it floods to all the neighboring spots that are not them that are also ground. Yeah. Okay. Yeah. So then we're going to make a new grid. So let grid equal grid.expand, and we have to flood. So I guess we would uh this is mutable. Grid dot flooding. Well, grid dot position grid dot grid 0. We'll just go to the corner, right? Hold on. That's not. If I go to the corner, then I'm gonna have problems with the whole reason why I put a whole ground around it was to avoid this. Ah, I just need one position that we can fill. Well, no, we can just deal with it. So 0 0, it has to be a ground. It's going to be flooded is true, and grid dot flooding insert 0 0, and then we're going to flood again, and then we're going to count all of the positions that are grounds that are not flooded, right? But we're only going to count the middle tiles. Actually, it doesn't matter. It matters because I don't want to count the grounds. Well, if it's completely surrounded, we just divide by 9 at the end. So all I need to do is count all of the non-flooded grounds and divide by 9. So um, grid dot oh, it doesn't know what expand means. So I guess we're consuming it. So it's self. Let's just have it return self for now, so that we can see. Yeah. So self dot grid grid dot grid dot reduce no fold. Well, actually, we're gonna count, right? So it's gonna be into iter map a row, a grid row, into iter again, flatten, and then filter Position. Position type equals position type ground and not position flooded. And then count and as U64. I think that's what I want. Flat map? Okay. I think this is all I need to do. So then the only to do is to expand, right? Yep. So then, oh, that and we have to support flooding the ground. Otherwise, it's going to be unreachable code right now. So expand is going to be, we're going to make a new grid. So might as well just make it, right? I never used width and height. Huh. Okay. That makes it easy. We don't need the width and height. Interesting. So I used the width and height initially for these takes internally, but I guess I never really needed them. Oh, but I was going to use them just now because it's convenient that way. Okay. So let width equals self dot width times 3. Let height self dot height times 3. Okay. And then let because I'm assembling a new grid from the old one here. I need a grid and a flooding. So flooding is hash set new. So this is self grid. Well, this is vec actually, right? Vec again. So we're going to initialize everything as ground. Width by height. Fill struct fields. So this is ground. Flooded false. And then we're going to end up with a self with auto-filled fields. Like that. Okay, but before, we can't just have it all ground. So we have to enumerate the old grid. So self dot grid dot into iter enumerate map. Actually, it's 4, right? 4 y and grid row in for x and position in grid row into iter, right? Enumerate. So it's basically if we'll match, right? Match the position dot position type. So if it's ground, we do nothing. Start is unreachable. Should be unreachable at this point. So north and south, we need to fill in basically 3 spots, right? So grid y times 3 x plus 1 equals the same kind of, basically we're expanding it. We're expanding a 1 by 1 to a 3 by 3, right? So north-south has to have like along the middle. Um, this has to also be times 3. There's gonna be a whole lot of times 3. So how about if I just make an x2 equals x times 3? Or how about double x? Y times 3. And then all these y times 3s are just y's, and all these x times 3s are xx's. So, and why don't I just expand them to be the center? Since that's the easiest, because then all these plus 1s go away, and this is just minus 1 and then plus 1. And these are all pos types. Grid has to be mutable for this to work. All right, and then we're going to do a similar thing for all these other ones. Why didn't it let me do that? I don't know. Sometimes it'd be like that, you know? Okay, so east-west, it's along the same center, but it's minus 1 and plus 1. And these are all east-west, right? Actually, it doesn't even matter. Because the way I'm going to do the flooding from the ground is if it's not a ground, then don't flood it. I guess yeah, it's fine. So northwest, the 3 of them are the center is a northwest. The one to the north is a north-south, and the one to the west, which is this direction, is a east-west. I don't know, I just kind of want to get the shape correct. So the center here is a southwest. So the one to the south is a north-south. No, south is plus 1. Um, west is minus 1. That's an east-west. And that's this is a south and west, and this is a north and south. Got it wrong. This is the center one. The center one should always be the same. Wait, I skipped one. North is a north-south, and that's this one's east is plus 1. That's east-west. So this is all north-south. This is all east-west. Um, north is up 1, and east is to the right 1. North is up 1 again. West is left 1. Southwest, that's down is south. And then west is to the left. And again, south. And then east is x plus 1 is an east-west. Okay. So then the final thing is flood has to work with the ground. And yeah, because this is going to start to flood the ground again. So it's no longer unreachable. I think the way it should work is it should just try flood in all 4 directions. But only if we're not at boundaries. So here's where I got to be careful. So let's go north first. So we'll say if y is greater than 0, then you can try flooding north. Try flood. Oh, it's also got to say if y is 0 and it has to be a well, I know what we'll do. We'll have a try flood from ground. Try flood ground. So this will only flood it if it is a ground also. So if it's not flooded and its type is a ground. Okay. So then that's north. South should be if y plus 1 is less than the height. West should be if it's greater than 0. East is if x plus 1 is less than width. No longer unreachable. Okay, now let's see if I got this right. No. Oh, it said 0? What? It got a 0. It ended up flooding everywhere. Well, crap. Well, I'm kind of thinking it would be nice to see that visualized. So, like, what if we visualize it here? So, grid visualize. Or yeah, what if we just implement the print line, I guess. Implement the display trait. That's the polite way to do it in Rust, right? Ah. Implement display for grid. So this would be like for grid row in self.grid for position in grid row. And then we're going to end up doing a print line. Well, right line F. How does the... I guess this has to be an OK, right? And this has to do a question mark. Yeah, we're going to borrow there. Yes. What's the warning here? Empty string. Try removing the string. Oh, okay. Cool. So then this is borrowed, right? So then every borrowed position, match positions type. Yeah, because we're gonna like only like show, we're gonna have ground, whether it's float or not, shown in a certain Yeah. So ground is if position dot flooded, else right to F. Let's do the tilde. If it's not, then it's a ground. Okay. Why is that a error? It has to be a string. Okay. Okay, so then all of these are writing something else. This one's unreachable. Should be unreachable. Okay, north, south is a pipe. East, west is a dash. Northeast is a L. Northwest is a J. Southwest is a 7. Southeast is a F. All right, so let's see what that looks like. It does look like it flooded everywhere. How did it get in there? Oh, there's a little break. Okay, yeah, it somehow got in there. Oh, I see the problem. The start one is flipped. It's a J and should be an F. Okay, that's the problem. The start thing got that logic's wrong. So where is that? Right here, right? Oh, this is flipped. Okay, so yeah, it's just flip them all. So southeast should be northwest, southwest should be northeast, northeast is southwest, northwest is southeast. All right. Okay, cool. So I just forgot to divide by oh no. Not only do we don't want to divide by 9. We only want to look at the centers because like this right here is a pipe and that's a pipe also, right? So we don't consider that. We only consider the centers. So um I guess I could just say filter. I'll just fill it in here. What I want to say. What do I want to say here? If position mod 3 is not equal to 1, or actually it's yeah, or position or actually it's not shoot, I do need the x and y now, don't I? Actually, you know what I can do is I can into iter and then just filter out enumerate filter. We get y in a grid row, right? Y mod 3 equals 1, right? And then flat map, um, really I want to map then. Why is this oh, because there's no pipe there. Okay, map it to grid row into iter enumerate and then filter again, right? Here it's an X and there's a position where we only want to take the middle positions. Okay, yeah, this is Y and then a grid row again. Really, I want to do a filter map if some grid row, else none. Or I think there's a easier way to do that. It's like this um then, right? Grid row. Then some. Yes. So then I get a grid row out of this. And it's again filter map. This then some position. Then with the position, I don't need that. What's wrong with my map here? Oh. Oops. Vector positions. Filter map. I think this map is too big. I think that needs to go to there. What is wrong with this? Actually, don't I want to do a flat map here? Yes. Because then I get an X in a position. Yep, okay. Let's try that. Okay, cool. I got the answer. And look, a nicely flooded picture along with it. Cool. So then I don't really need to see this unless I'm debugging. Hopefully I don't have to debug the real thing because that'd be a pain in the butt. All right, so then we're doing it on our real part 2. 33. All right, 33 it is. Seems low to me, but nope, it's not the right answer. Grrr. It's not 33. The unit test passed. Let's try like with the more yeah, this one which has 10 of them in it, right? Yeah, this one. More aggressive answer. I mean example, more aggressive example. Input 4. So this says this one should have 10 in it. Okay, and it only came out with 1. So here's where I want to comment this out and see that flooding happen again. See what I do. What did I do wrong? Oh, wacky. So what are the ones we should have seen? There's an I. So right in here, one there. Wait, what? Why are there these vertical pipes inside? Oh, because there were pipes there. Oh, those pipes should have been ignored. Okay, that's the problem. Um, they're these interior garbage ones. They got replaced. It should only do that if it wasn't part of if it was part of the loop. Okay, then I know how to fix it. So it's when we did the expand. At some point here, we like, yeah, hmm, yeah, we should only do this. We should only go into this if the original position was either a ground or it was flooded. So how do I say that? I guess we do it here. If self, well, we have that, right? If position type is equal to ground. Actually, if it's ground, we're doing nothing, right? So it's if it's flooded. If the original one is flooded, that's what it is. If the original one is not flooded, continue. There we go. Now let's see if I get the right answer. Yes. And we see the correct picture, I hope. Yeah, so now all that interior garbage has been eliminated. Okay, cool. So then let's hide the printing again and run it one more time. $429. Yay! Wow, and I had like no chat the entire time that I did this for an hour and 33 minutes. You guys like get the Lurkers of the Year award. Did the entire puzzle without anyone chatting. Makes me think that the stream isn't working. Hey, maybe the stream isn't working. Maybe I've been like streaming to myself the whole time. It says it's going. We only dropped 59 frames, just like everyone's lurking. All right, let's see how we did. Sir Flabbergast, Billy Harrington Enjoyer. Well, you guys all get Lurkers of the Year award. Hey, look at that! I got a really good rank on part 2. Aneurysm 9. Hey, well, close to 3009. So that's my best time yet this year. Sub 2000. I thought that was pretty fun. I like the idea of expanding the maze as an interpretation of when they said to squeeze through. When they said down here like the water can squeeze through, I'm like, oh, that's easy. I just expand it from 1 by 1 to 3 by 3, and then it'll squeeze through. So cool. Wow. 10 minutes for the fastest person? So this was tough for a lot of people then. Oh, part 2 is what part 2, everyone's getting stuck on part 2? Wow. I don't know. I thought that was fun. I can remove that now. All my test will pass, right? Cool. Uh, as much as I like having this print line, we don't need it. What was this complaint the whole time about? Explicit call to into iterator and function accepting into. So it just wants me to say into iterator? But then it doesn't, then this chain doesn't work. Useless conversion. Consider removing the into iterator. Just grid row? Is grid row already an iterator? No, it's a vector. Oh, a vector already implements into iterator. Got it. Okay. I get it. AoC challenges are neat, but a little beyond you. As we get towards like day 15, 20, it should get really hard. But I think days 1 through 4 were pretty approachable. How am I doing? Private leaderboard on Primogen's list. 16th place. Where was I before? I don't even remember where I was, but looks like 5 other people beat me. They've already finished it. Quite a few people not yet finished with part 2, so maybe we should raid people who are still working on part 2 and watch them solve it. I kind of feel like doing that. So let's see, who's still working on part 2? Bad Cop is, Epsilon 1 is, who else? Stu Squared is. Temporalix is. Oh, is who is it? Juicebox Hero? No, not working on it right now. Oh, I am. I only got 22 people. So sad. Didn't I raid Bad Cop yesterday? Why not? Why not raid them again? I think they're still working on it, but I won't really know unless I listen in anyway. Okay, we're gonna go raid someone who's hopefully still working on part 2 and see how they solve it. I will see you guys probably not tomorrow, but Monday. I'll probably catch up and do 11 and 12 on Monday. Bye.